Hello and welcome to Economics 21, the Bitcoin Standard. This is lecture 2 of the course, and the topic of the lecture is primitive money, which is the topic of the second chapter in the book, the Bitcoin Standard. In today's lecture, we're going to discuss some of the primitive forms of money that have been used across time and try and understand how these forms of money lost their monetary role, because I believe this is a very important lesson that can help us understand how Bitcoin functions and how Bitcoin operates and the economic incentives that surround Bitcoin. The first kind of money that we're going to be discussing is something that is called the rhinestone. Rhinestones are round cylindrical discs made out of limestone, and they have existed as a form of money, or they have existed as a form of money on an island called Yap in the Pacific Ocean, in what is today called the Micronesian Republic. And in Yap, in the island of Yap, these limestones were used as a form of money for many centuries, and they functioned as useful monetary media for properties that are very relevant, I find, to Bitcoin. In fact, when in the later chapters we're going to try and explain how Bitcoin functions, it's going to be quite helpful to understand how these rhinestones function as money, to understand how Bitcoin functions. Because the ownership of these rhinestones, these stones were very large blocks, and they were heavier than a human being, and they required several people to work together to carry them. In fact, they had the hole in the middle so that large tree trunks could be inserted, and so that groups of people would carry them from both sides of the tree trunk. So moving these rhinestones wasn't very easy, and which obviously would, you would expect that this would not make a good medium of exchange, because people aren't able to move it around easily. However, it did make a popular medium of exchange in Yap for many centuries, maybe even millennia. And the reason for it is that the ownership of the rock did not require the rock to move. The rocks were placed in prominent places in the town or in the island, in like the central squares or the areas that are common to all members of the town, where everybody can see the rock. And the ownership of the rock would change without the rock itself moving. And so the way that it functioned was that when somebody who owned one of these rocks wanted to use it as a form of payment for something else, if I wanted to buy somebody's house and I own this rock, the town would meet in the center square around the rock, and I would announce that this is no longer my rock and that it is the other person's rock. And if everybody's there, everybody can see it, everybody will remember it, this becomes the rock of the other person, and the ownership has been transferred without the rock moving. And I think this is useful in helping understand how Bitcoin functions, because ultimately, first of all, there are no physical Bitcoins to move around, and so nothing moves from my computer to yours if I make a payment to you in Bitcoin. And secondly, because the way that this ownership of the Yap stone is established, similar to the ownership of Bitcoin, is through consensus. It's through everybody in the town in Yap gets together and they agree that this stone belongs to this person. Similarly, the Bitcoin network gets together every 10 minutes. It performs a consensus process similar to what people in Yap do with their large rocks. In Bitcoin, every 10 minutes we get the nodes of the network arrive on a new ledger of ownership, or a new record of ownership over who owns this rock. And from that, after that consensus is arrived at, economic activity continues, and then another consensus can be arrived at after that rock is transferred to another person. Something similar happens with Bitcoin. Every 10 minutes, the ownership of the digital rocks that are Bitcoins is changed, even though really nothing really actually changes place. There are no physical coins, and to the extent, even if you want to think about digital coins within the system, the digital coins don't move from my Bitcoin node to your Bitcoin node when I make a transaction. The digital coins essentially exist on a ledger that is shared amongst all nodes. So that ledger can be likened to the town square or the main square where these rocks would be displayed. And so I think it's useful to understand it's useful to understand the rhinestones because they help us understand Bitcoin. But the more interesting reason I included them in this chapter is for the story of how they lost their monetary role. And that I think is quite interesting to think about because the entire, my book is built on the idea of the importance of the stock to flow to the monetary role of Bitcoin. And these give us a good example of what the problem with the stock to flow is for easy monies and why they can lose their value. So, first of all, let's assess the salability of these rocks compared to the previous criteria for salability that we had discussed in lecture 1. If you remember, we discussed salability across space, salability across scales, and salability across time. So when we think about the YAP stones, if we think about their salability across space, the small rocks, the rocks, many of them were large, but of course some of them were also small rocks that would be used for small transactions. So yeah, you could say that the small rocks are saleable in terms of space because you can move them around easily across the town, but they're the larger ones are also arguably still saleable across space because even though they couldn't be moved, they still they were still liquid everywhere on the island because they didn't have to move for them to be used as money. So you could be anywhere in the island and pay anybody who's anywhere else in the island as long as we agree on the consensus. But of course, it's not as ideal as if the form of payment could have been. You could just meet the person anywhere and give it to them, rather than having to go to the town square and get everybody in town. So the salability obviously is not ideal, but then again you have to remember that in a society that didn't have industrial production of metals, this is about as good as it got. This is the hardest thing that they could probably find. And that brings us to the issue of its salability across time, and that is why these things were really ultimately a form of money. Because first of all, they don't ruin. It's much harder to ruin rocks than it is to ruin agricultural products. Secondly, they are the key thing about them that gave them this monetary property is that they didn't exist on the island of Yap. You couldn't produce them in Yap. You couldn't make these rocks in the island of Yap because there was no limestone on the island. And so if they wanted to get more of the limestone, they have to go to Palau, a nearby island, and get the limestone from the island and then carry it all the way back to their island, which was an extremely difficult thing to do. And that's why it was money. So we can understand that their emergence as money, it was not some random choice, it was not some collective hallucination as Marxists like to hallucinate. The choice of money has very real properties that make it a good or a bad choice. And there's a reason that people on this island chose this, which is that it was not something that was easy for them to make on their island. It didn't exist on the island. And so therefore, making more of it or inflating the supply or increasing the supply necessitated a very significant cost. And that is what made this that is what made it suitable as a form of money. This is why it is hard to produce, and therefore on the island of Yap, it is useful as money, because it's hard to produce on Yap. It would have been a useless money, and that's why really it never emerged as money as far as we can tell on Palau itself. Why? Because Palau is effectively has these rocks in its own land, and so people could always dig more and find more. And so if I started using these rocks as money in Palau, it would be very, very easy for others to dig more, inflate the supply, bring the price down. So their salability across time really is what gave them the monetary role, because they're at that time and that place they could offer the best technology for making more of these they could offer the best technology for having a harder money. So they were the hardest technology that you could use. And my argument is that at any point in time, whatever gets used as money is whatever is the hardest to produce. And so if you think about them if you think then about the salability across scales, we see that these things, well, they're okay in the sense that there are small rocks and there are big rocks, and they can be, you can use several small rocks for a payment, and there are different values. But it's not good because it's not easily divisible. You can't crack a rock into smaller pieces, and then you can't bring the pieces back together into a big rock. So again, on the salability of scales, we can see how these things were pretty decent. The three aspects of salability were pretty decent in the rhinestone, but they were not ideal. And you can imagine how a modern form of money, like gold or silver, would be much better than this, or even some of the government monies. So this, it's important to remember that now we're going to move on to the story of how they got demonetized after assessing their scalability. And the story that I mentioned in the book, there was a movie made from it, and there was a novel based on it, and a movie as well. And it's a story of a man called Captain O'Keefe, who was an Irish-American sailor who was shipwrecked one day and woke up in Yap Island and found that they had an enormous amount of coconuts, and he wanted to sell those coconuts, but the people lived in basically a paradise, and they had no use for anything that he brought in. The only thing that they valued, other than their foodstuffs and their coconuts and the things in which they survived, the only other thing that they valued were these limestones. So O'Keefe knew that if he wanted to get them to work for him and sell him their coconuts, he needed to give them limestones. He needed to give them more of the limestones that they like. And so what he did was he utilized modern industrial technology to go to the island of Palau, where those rocks exist, and he produced very large quantities of them and brought them back to Yap and gave them to the locals in exchange for the coconut. But what was the effect of this? Well, I think the lesson there is very important for economics and economists to pay attention to. And then the consequence was that it destroyed Yap stones as money. It destroyed these rice stones as a form of money on the island of Yap because he inflated the supply. He decreased the stock-to-flow ratio. The flow of new rocks that came in was so large that it devalued the existing rocks. And so therefore, these became a lousy store of value, and the island itself lost its form of money. Of course, the story the story itself of the arrival of O'Keefe is a quite dramatic, and this is why I chose to use it, because it's a very dramatic shift of losing the monetary status very quickly. But in reality, that process was going to happen anyway to the Yap Island, and just like it happened pretty much everywhere in the world where an easy form of money existed, because in all of these places, the low stock-to-flow ratio of the money was always going to lead to it getting demonetized and losing its value compared to other monies. And so, and primarily, of course, that is because of the advancement of industrial production techniques. So as we moved towards the 17th and 18th and 19th century, with industrialization allowing us to produce more and more of everything and produce at a much higher efficiency and much lower cost, the hardness of pretty much every other money than gold was compromised. The hardness of every money was compromised because each one of them could be produced at increasing capacities. And so with and we'll get back to this point in a bit, but we see this with the limestones. It was only a matter of time before somebody was able to quarry limestones at a very low cost from Yap Island, from Palau, and ship them to Yap. And so this was inevitably going to happen. In fact, we can see that the large size of the rocks itself was an indicator that this thing was happening. You can imagine that initially when these limestones were being used as money, it was the smaller sizes that were being used, but as more and more people started going to Palau, getting more rocks from Palau, moving them to the value of these rocks would decline, and eventually you needed very large rocks in order to carry out transactions. And this, of course, is a quite wasteful monetary system if you think about it from the perspective of modern economics, because, why would you be spending all this time and money on acquiring those stones? And, of course, it's absolutely correct. If you have an alternative like gold and silver or government money that is run by not complete kleptocracy, then yes, you're absolutely correct. Maybe the costs of acquiring those stones are a waste because it's not very hard money and you're spending all this time and you're constantly increasing the size of the money, and that doesn't make much sense. However, when you think about it from terms of the alternatives that actually existed back then for the people of Yap, it makes more sense because for them, the alternative to getting these rocks was using even easier forms of money, which would have constituted worse stores of value, which would have been easier for other people to produce, and therefore would have been worse for people of Yap in terms of the ability to store value and delay gratification, lower the time preference, topics we're going to get into in detail in this course. So, similar story is the story of glass beads in West Africa. Glass beads were being used as money in West Africa because they were rare, because glass-making technology was not popular, was not common in West Africa at that time. And so whenever people from there would travel abroad, they would bring them with them because they were valuable, and because they were scarce, because they couldn't be made locally, they had a mechanism of restricting their, essentially increasing their saleability across time. So these things were probably one of the most saleable things across time in West Africa at that time, and that's why they became chosen as money, because it was very hard to increase the supply, just like with the Yap stones, and because the island didn't have those rocks, West Africans didn't have the technology to make glass beads, and so these were used as money, because if you put your value in them, if you stored it in them, it was hard for other people to make more of them. Until, of course, people who had glass-making technology and had very cheap glass-making technology started visiting more often, and that's when they started providing more and more glass beads to West Africa, and that led to an enormous increase in the number of beads, a drop in the value of the beads, and effectively, it allowed the people who who brought in the beads from Europe to effectively expropriate all the wealth that was stored in the beads. That's really the key thing. And that's also what O'Keefe did when he managed to make the Yap stones cheaply. He gave them to the people of Yap, took their coconuts, but it was a very winning trade for him because it was cheaper for him to make those stones. And incidentally, the village chiefs, as we mentioned in the book, they refused those stones precisely because they were easier to produce. It didn't conform to the consensus rules of the Rhinestone network, if you want. It was much harder. It was much easier for O'Keefe to produce them, and so really the problem that the Yap stones had in terms of their monetary technology is that they didn't have something like the difficulty adjustment. They're a primitive form of money in that regard, similar to your central bank's money, which doesn't have this advanced technology, this difficulty adjustment, which we'll get to, which I find to be the most fascinating aspect of Bitcoin. But because the Yap stone doesn't have the difficulty adjustment, as somebody finds an easier way of making limestones, the result is we end up with more limestone and the value of the limestone declines, and so we end up needing to use very large rocks. The same is true in the case of the glass beads. So the move towards glass beads resulted in the expropriation of the wealth of the people who used it. And eventually, we see that as industrialization spread, we can produce more of anything, which lowered the stock-to-flow ratio for pretty much anything. Everything was being able to be produced at a lower cost, which means that scarcity becomes very hard for anything. Even the rare things, even things that are rare to find on Earth, start becoming easier to produce, like silver and gold. Their supply increases. And so, but before we move towards discussing gold in particular, we had the stage where we moved from these primitive monies, seashells and so on, towards things like towards metal money. And we see that metals really won the protocol wars of money. Metals became money for a very good reason, because industrialization allows us to make them into, give them the properties that we want, to meld them into the shapes that we want. And I think perhaps the most important killer app of metal money is that they can be coined into uniform sizes and weights. And that's really something that other primitive forms of money don't have. So seashells vary with one another in terms of size and rarity and so on. Yap stones, all other kinds of glass beads, all other kinds of money will vary between one another. But metals can be made uniform, and this makes them far more suited to becoming units of account, and that was what allows very complex kinds of economic calculations to take place. And so as we move towards metals, metals overtake all of the primitive forms of money that we have, but then even within metals, our ability to make more and more destroys the monetary role of most metals. So initially we start off with metals being used by weight because they were useful, but then we move towards the coinage, as I was mentioning. And through this we see that by the time we see coins being made, only a few metals ever make it into coins. Mainly iron initially, and then copper, silver, and then gold. And iron, we have very little record of very few coins that were used from iron, because it's very abundant in earth and very easy to produce. And so it was a cheaper form of money that was demonetized quite quickly, because its stock to flow is very low, because more and more of it can be produced. And then the second thing, the second kind of least valuable monetary asset was copper, probably, but that was also demonetized by the 17th, 18th century as it's meant to decline because it was also easy to produce. Silver then started, was the one that held on to a monetary premium for longer, and then of course gold was the main money. And so the reason why silver and gold managed to hold on for their premium ultimately is not just about the difficulty of producing them, because they are difficult to produce, because they're expensive to produce and they're hard to find, but it is also about the fact that it is not easy to destroy them, not easy to reduce the supply that exists from them. And so silver, it's generally durable, non-reactive. It's slightly inert. It's not completely inert like gold, but it's not very easy to destroy silver, at least compared to copper and iron and other kinds of metal. Gold, on the other hand, is completely indestructible. Those are the two properties that gave those metals their monetary roles. In other words, because you find it hard to destroy the stockpile that is produced, that has been produced in the past, sticks around, and so new production is a smaller fraction of the stockpile that sticks around. You can say this is the case. This was the case for silver, but then over time it stopped being the case, because we continued to produce more and more of silver, and it always had a lower stock-to-flow ratio than gold. Gold has the highest stock-to-flow ratio because gold is different from all other metals in that it is the only one that is indestructible, or at least not the only one, but the only one from the ancient metals that we've had for a very long time. We'll get to that point. So if you want to think about the process, here's how we can visually think of the issue of the stock to flow. This is the stock of any kind of metal. And every year you have a new input into this metal, which is what we call the flow, or the new production, right? So every year we have new production that is being added to the existing stockpile. The existing stockpile is the sum of all of the production that we have done over all of the many years. And then what is lost from the stockpile every year is the consumption. Every year something gets consumed. This relationship between the flow, or the new production, and the consumption, and the stockpile helps us understand what things will develop a monetary role. So let's begin by thinking of something like copper or zinc or iron, as a regular kind of consumed metal. As it gets produced, more and more of it is produced, but also more and more of it is consumed. And so we are constantly witnessing a reduction in the stockpile and an increase in the stockpile. And the end result of it is that if you think in terms of what is the stockpile in terms of the new production, roughly the stock to flow is in the order of 1. This is for what we can call industrial metals. For pretty much everything in the world, we're going to go to a stock-to-flow ratio, let's use this, stock-to-flow ratio of roughly equal to 1. In other words, annual new production every year is roughly equal to the stockpiles that we have at the beginning of a year. It's not because the stockpile is everything that we have produced in history, it's because most of what we produced in history has been consumed, okay? So, if you think about a commodity like oil, at the beginning of the year 2019, how much oil stockpiles existed in the world? You know, people had oil in their gas tanks, people have oil in their gas stations, in strategic reserves for companies and governments and so on all over the world. But that oil is constantly being consumed. And so every day, more of it is being consumed and then more new stuff is being produced. If you measure the total stockpiles of oil around the world versus new production, it's roughly in the same order of magnitude. Around 1, maybe somewhere between 0.5 or 1.5 to 2, for pretty much every commodity in the world, every industrial metal or commodity. This is what the stock-to-flow ratio is because of the consumption rate. The fact that the consumption is always taking place, it's always reducing the stock, and so the flow is being added into a stock that is constantly being depleted. But what about in the case of something like gold? In the case of gold, on the other hand, what we have is quite different. In the case of gold, the stock to flow is roughly equal to 60 or something like that. In other words, the new annual production every year is about 1.5% of the total stockpiles. And that's really why the gold ends up being the metal that gets used as money, because every new year, the new supply is only a tiny fraction of the existing stockpiles. And so if people move into gold as money, if people use it as a store of value and the value of gold rises, producers of gold will try and make more gold, but the quantity of gold that they make is tiny compared to the total stockpile, so they're unable to affect the market significantly. With every other metal that has a stock to flow close to 1, the new producers will increase the stockpiles by very significant quantities. It's not 1% like in the case of gold, it's going to be like 50%, 100%, or 200%, or 300%. You can get this massive increase in the stockpile, which floods the market and brings the price crashing down. So anything that is an industrial commodity will have a stock to flow around 1. Only if you have a stock to flow that develops higher consistently will you be able to accrue a monetary role. And that is the situation with gold, which develops a monetary role because it continues to have a new flow that is very tiny compared to the stockpile. So as we see, that many people think of the reason that gold is money. When they discuss why gold is money, they think of it in terms of gold is money because it's rare on Earth. It's not true. It's not because it's rare. It's because the stockpile is very large compared to the flow. If it was about rarity, then we would see other rare metals like platinum and palladium being used as money. And we're going to discuss this in a bit. But the issue is not it's not necessarily the rarity. It is more important than rarity, it seems, is the indestructibleness. And the fact that because gold isn't destroyed, you're constantly adding to the stockpile. And that's really ultimately why, I should have mentioned this earlier, the reason in the case of gold, the reason the stockpile is much larger is that the consumption is equal to 0 for gold. For gold, the consumption every year is equal to 0, and that's really the key thing that has given gold its monetary properties. Because annual consumption is equal to 0, no matter what happens with the new flow, it is just piling up into the stockpile, and the stockpile just keeps getting bigger every year. There's zero leakage, if you want. There's zero exit from the stockpile. And so basically, the gold continues to become better money because with more flow, we just add up to the stockpile, making the stockpile larger compared to the flow overall because zero consumption takes place. So gold, being chemically inert, being unreactive, it doesn't rust, can't be destroyed in any way. If you drop a nuclear bomb over a place, everything burns, everything smolders, and then a century later you come back after all the radioactive poisoning is gone, that whatever gold was there will still be intact gold, as good a gold as it was before the nuclear bomb. And so the fact that gold can't be used in industry, it can't be consumed, it can't have its quantities reduced, it can't corrode, it can't rust, means that the consumption is always equal to zero, the stockpile is always rising, and the flow is small. So the reason that gives gold its monetary role is not just the rarity, it's also the indestructibility. And that's why I think an important point to keep in mind, many people bring this up as a reason why Bitcoin, why gold would lose its monetary role, is the notion of asteroid mining, that if we get hit by an asteroid with a lot of gold, we could have an enormous amount of gold and then gold becomes cheap and then gold stops being money. Or if we start mining asteroids or other planets, they might have a lot of gold and then that becomes cheap. Regardless of the science fiction aspect of things, whether this is even realistic as an engineering challenge or not, putting all of that aside, even assuming it was true, it was all possible, in fact, I think such an asteroid would, in fact, improve gold's monetary role. Because, as I said, it's not the rarity of gold that makes it money, it's the stock-to-flow ratio. So if we get hit by a giant asteroid, and this asteroid comes into the Earth, this asteroid hits the Earth, and it has more gold than all of the planet Earth combined. So imagine that the stock here, this is equal to 2 times the stock of the Earth. And so now the stockpile of gold on Earth has tripled, effectively. The total gold that we have has tripled. What will this do to the stock-to-flow ratio? If stocks triple, the stock-to-flow will also triple. So if we get a big chunk of gold that comes onto the Earth, yes, at the beginning, the people who get it will have an enormous amount of cheap gold and they're going to sell it on the market and they're going to make a big profit. And then what? And then the market now has 3 times the stockpile that it has, and annual production is still the same. So after this asteroid has been absorbed, what happens? We go to a much higher stock-to-flow ratio, where annual new production of gold is now about 0.5% compared to the global stockpiles. And that actually improves gold's monetary role because it makes the new production less significant as part of the overall liquid market, and therefore makes new supply less likely to depress the demand. So gold ends up remaining as money because of its indestructibility. Ultimately, as you increase the stockpile, it doesn't matter in the case of gold very much, because the short-term impact would, yes, be a reduction in the price, but the long-term impact is an improvement of the monetary properties because you're increasing the stockpile compared to the new flow. So, and I think there's a good example to think about it. Similar to this is when we have the flows of gold from the old world, from the new world to the old world. When Europeans went to the North American and South American lands where they found a lot of gold, they brought that gold back to Europe. And arguably, it's very hard to get decent estimates, but arguably there was a big increase in the supply of gold on the markets in Europe, but it did not lead to gold losing its monetary role. It might have caused economic problems for people who held gold at that time. It might have dropped the price of gold at a certain point in time, and that's natural because you had a bunch of people come in with new gold and with more purchasing power. So effectively, if you or a European who didn't have gold, and then your neighbor went to the Americas and got a big chunk of gold. When they came in, they outbid you for things, and so that raised prices for things. So it must have not been nice. Yet, it arguably improved gold's raw monetary status over time because it just increased the stockpiles of gold that are available in the market and made new annual production less significant. So, effectively, it's the absence of consumption that makes gold escape what I mentioned, what I call the easy money trap. The easy money trap is the idea that with any money, if the value of the money goes up, new production will make it, if it's an easy money, new production will make it hard, will make it easy to increase the supply, therefore making it hard to maintain value in it. So then, why then can we understand, how then can we understand the fact that metals like platinum or palladium, which are also non-destructible like gold, why have these metals not developed any significant monetary role? Why does nobody have platinum reserves or palladium reserves? Even though similar to gold, they are also indestructible. And I think the answer for that is that it is not the indestructibility itself that makes gold money. It is the relationship between the stock to flow. And what platinum and palladium don't have, which gold does have, is the history of thousands of years of industrial production adding up to the stockpile. So in the case of platinum or palladium, yes, they're indestructible and the consumption is very small, but if you were to compare them to gold, you would find, if we're going to use another, in terms of the total market value, palladium is probably a tiny little fraction of gold, and I'm probably overstating the size of palladium compared to gold or platinum here graphically by scale. There are very, very few tons of palladium have been produced compared to gold over history because these two metals, commercial production of them only really started in the 1800s. And so in the 1800s, the size of the palladium market was practically zero. It was a tiny little dot compared to the ocean that is the gold market. So what does this mean? It means that the new flow of palladium that goes in, if we're going to discuss it here, if we're going to illustrate as the white box is gold and the green box is palladium, the new flow of palladium, because the stock is so small, means that the new flow can be much larger. You're starting off from a very small base, and so the annual percentage increases can be very significant. You could get much more than 1%. Similar to how the inflation rate for Bitcoin was very fast, was very high for the first couple of years. Because you're starting off from zero, you're going to be increasing the percentage of increase is going to be very high. And so the problem that platinum and palladium face and that prevents them from becoming money is that as they're small, if they're going to start growing, they can't maintain their value while also growing in size, because growing in size requires increasing amounts of flow to be brought in, and there's no way to stop that flow from submerging the value and crashing it down, because palladium and platinum are also, just like the rhinestones, they're also primitive forms of money because they also don't have the difficulty adjustment. As the price of palladium rises, people can continue to make palladium until they bring the price down. Whereas as the price of gold, as the price of Bitcoin rises, the difficulty adjusts and the new supply, the new flow is restricted. And that's really the key difference. And in fact, we do have an example of people trying it. And this is why I think it's really important to understand that something like stock to flow and the monetary properties and salability, because it protects you from believing in the crazy stories of Marxists and other kinds of economists who think that money is just a hallucination, or people can decide that anything is money. That if society tomorrow decided that we're going to be using light bulbs as money, then light bulbs become money because we all decided to hallucinate them. And that's just ridiculous. There are very good reasons that even when people decide what something is, it won't work as money, no matter how much you decide to collectively hallucinate, as these Marxists like to say. And one other great example of this is the story of platinum in Russia in the 1820s. So platinum was discovered in the 1700s, and its commercial production only really started around the early 1800s. It was initially only discovered in the Americas, and then the Russians discovered it in the early 1800s, and they thought, well, this thing is very rare, just like gold, and therefore, if it's very rare, then we can make money out of it. They assumed that the reason that gold was money was because it is rare, and intuitively this makes sense. It's rare, therefore it's expensive, therefore you want to use it as money. It's also wrong. Gold is not money because it's rare. Gold is money because it has a high stock-to-flow ratio. And that's something that platinum didn't have. So in the 1820s, Russia collectively hallucinated, as Marxists would tell you, that platinum was money, and guess what happened? Their hallucination didn't take off. It didn't work, and the coins were discontinued. Why? Because in the 1820s, the stockpile of platinum was tiny, and so the news flows would always flood the market and bring the price down. By the 1840s, platinum had lost value, and it had not succeeded as an experiment, and they discontinued the coins. And this really helps us understand why gold continues to maintain its monetary role and why it's really hard for other metals to beat it. Even if you have almost the same kind of physical properties that gold has, indestructible, very rare, very expensive to produce, you don't have the 10,000 year or 6,000 year head start that gold has had in building up its stockpile. And that's why other metals are not going to replace gold's monetary role in this regard, because they need to build up the stockpile that makes the new flow insignificant compared to their stockpile. And this is also why an asteroid, if you think about it, is not going to take away gold's monetary role. If a new asteroid comes in, you just increase the stock to flow. And that's why I think, I think this framework of thinking of money in terms of saleability, and in particular, in the last couple of hundred years, in terms of saleability across time and holding on to value, I think this is a much more useful framework for understanding money than any of the other properties for trying to explain how different kinds of monies emerge. And it's very good at explaining all the different observations we find. It's very good at explaining why gold and silver were money, and it shows us why silver lost its monetary role, as we're going to be discussing in chapter 4 as we move towards this. One final point is to remember the distinction in terms of the monetary role between gold and Bitcoin. We haven't gone into Bitcoin yet, but it's important to point this out now. With gold, the way that we maintain the very high stock-to-flow ratio is through consumption being equal to 0, therefore making the flow irrelevant. Even if we get 10 asteroids, just makes the stock rise larger. As long as the consumption is equal to 0, the flow is always going to be small compared to the stock. Even if we increase it a lot for a year, it'll be an aberration, but then the stock rises and the flow becomes smaller. So with gold, its own the fact that there's 0 consumption is what gives it the stock. With Bitcoin, what gives it the fact that there's 0 consumption is what gives it the high stock-to-flow ratio. With gold, with Bitcoin, what we count on is the reduction in the flow to 0. It's not just that we have the consumption; we also have the reduction in the flow to 0, which is why you could say that Bitcoin has 2 ways of enforcing its high stock-to-flow ratio. But the difference is that with Bitcoin, any unplanned increase in the flow will basically compromise the value proposition. Whereas with gold, no increases in the flow can compromise the value proposition. So we'll discuss these matters in more detail in the future lectures. In the next class, we're going to move in chapter 3. Today we started actually with chapter 3, and in the next week, and then I'm going to get into more detail in metals and what the impact of moving towards a monetary system built on metals, in particular gold, was, and all the civilizational advantages of being able to use a form of money like gold that has a high stock-to-flow ratio that allows people to save and maintain their value across time. So thank you very much for joining me for this lecture. I would urge you to stay updated with the course on the website, on the course website, and to please check out the course forums. Go onto the forums, saifeddin.com/forums, and if you haven't signed up yet, do sign up, and you can get into the discussion of these notes and lectures and all the topics of the book and the course